I say we start with a simple promise declaration. How to declare a promise that is resolved without rejection, without having a rejection. We just need to create a function, as an example, that does something, returns a value. For now, maybe we could just use try catch and just resolve this returning of the value. Example, I want to make it a little bit complicated so we don't lose time. We have an array and we have to return, with a loop, we have to return this array one by one, the values one by one. But we want also to resolve this async function when the array has finished, the loop has finished. I think that is useful also to use it as a tool.
So basically, we want to have an array, loop over the array, and run some asynchronous operations during this loop. So that's the extra like thing that you bring to the table, right? We know about arrays and loops.
Yes.
But
yes,
what
yes.
do we do when we have? Okay, so I'm keeping this. We are going to have like a week dedicated to asynchronous, everything related to asynchronous programming, promises, async await. I'm keeping this. I'm not sure whether we will eventually, reach to this point and explain or go through this array loop, asynchronous array loop. It's a little bit advanced. I want us to understand promises before going into asynchronous loops. So I'm keeping this here in my notes. We'll see, maybe we'll have time to also work with a simple example. Now, I want to start by asking you, and feel free to share whatever comes to mind. This is not a quiz, this is not to how to show we are smart. I want to give me like a description of what you think a promise is. Like, what have you understood so far, what a promise is, so that we all try to see whether we are on the same page, we have some different ideas, maybe someone has like a nicer way of describing it. So I want everyone to share like their understanding of promises, even if it's very vague, even if it's very, very blurry. Just share what you think a promise is, so that we try to all kind of understand this weird thing in JavaScript. How would you describe promise to someone that doesn't have any idea of promises? What do you think it's kind of doing, or who would like to start? Leon, would you like us to give us to give your description of a promise? Like, how would you describe promise to someone that just started JavaScript and they're asking, okay, what's the promise in JavaScript? What is your...
A promise is what the word says. You promise something and you have to do what you promise, and when this promise is fulfilled, if this promise is fulfilled, you just say, I have done what I promised. So if you don't, if you didn't do what you promised, you reject it, and you say it's something is wrong. I didn't do what I promised.
Exactly. I mean, that's the basic idea. That's a really good start. Let me Google a tip that we've already mentioned a couple of times. Like, whenever you're against some kind of like new concept, especially difficult concept in computers, I suggest that you try Googling. Doesn't work all the time, but if you try to search for Google for, let's say, JavaScript promises, it's nice to start with images. So switch to the images Google search, and especially promises. you will try to go through some of the images that will probably help you understand promises. Most of the time you'll find some nice images. So let me open up a couple of random images that I see here. So, I mean, this is exactly what Leon described. So there's this kid, Mom, I promised to clean my room. That's nice. So that's a promise that he gives to his mother. And then if the promise is fulfilled, if he does actually eventually cleans his room, he goes out and play. So that's the fulfillment part. So on the left part is the yes, promise fulfilled. I cleaned my room. And then on the right part, the promise is rejected, as we say. So he didn't fulfill his promise, so he has to do the laundry. Let's see another example. Let me find a more kind of like non-technical, more real world, and then we'll go and see the technical. Like, this is also a nice one. I will be sharing the images with you. So there's a pending promise. So there is a printer, and well, obviously the printer is promising to print something, and they have this really nice diagram. On one hand, on the left, it actually fulfills the promise of printing the paper, so it resolves, and then you get the printed document, and then you put it in a real folder, I guess. So the printer fulfills its promise, and it gives you back the printed document. On the other hand, if there's a problem with the printer, there's a rejection. There's a reject branch here, and then there's no printing. The printer is out of ink or whatever, and then we go with the cuts. This is how we handle rejections. So we handle rejections, as you can see, with the cuts method, and we handle resolutions, fulfillment with then. We're going to be seeing this in code. So promise, I will print something. I either fulfill the promise and I print this, and then you use then to do something with a printed paper, or you cannot fulfill the promise, you reject, and then you have to use something called the cuts method to actually do something with a problem. Maybe see what went wrong, out of ink, out of paper, something that happens when you try to print and things don't go well. So this one is kind of like a strictly a real world analogy, just a promise one human being gives to another human being. This is also real world, but we see this kind of like JavaScript terms here, like reject, resolve, then cuts. Let's see if we can get a little bit more technical at this point. So I will try this one, which has some nice colors. Okay, so this is like the strictly technical JavaScript version of this. So we have the promise at the left. So something promises that it will do something, and you will see there's a pending word on top of it. So whenever we promise that we do something and we go there and do it, we say that we're in pending. So let me, because I don't know what pending really means. So the second tip that we've already shared with you is whenever there's a new English word that is used to understand some computer concept, it's a good thing to, if you are not familiar or comfortable with that word, is to find the actual definition of the English word. So I will go and Google for define pending, because maybe it's the first time I hear the word pending in English. So let me zoom in. Okay, so I will go to 200. So pending in English, okay, we start with plain English. Pending is an adjective meaning awaiting decision or settlement. 9 cases were still pending. So in a court case, you know, something like this. So pending means awaiting for something to settle, for a decision to be made. There's also like a preposition until something happens. So if you weren't familiar with pending before, it's not a kind of like very common word, let's see, for non-English speakers. So you now know that pending seems something is about to happen. So if I go back here, you will see that the promise starts in the pending mode. We're waiting for this to be fulfilled, resolved, settled, and so forth. And now we have two branches. This is very important. A promise is like an if statement. There's a resolved and there's a rejected. A resolved means we actually clean our room, print the document, do whatever the promise to do, and we go into a resolved state. So if you were like in your room and you have cleaned your room, you would say to your mother, hey, this is resolved. The cleaning of the room is resolved. I can go out and play. And then if you happen not to do this, the thing that you promised, the printer didn't actually print the paper, then we go into this other direction of these branches, which is the rejection. Something went wrong and got rejected. In promises, we always have these two cases. Either one or the other will happen, never both of them, okay? There's no such thing, apart from Schrodinger's cats, there's no such thing as cleaned my room and not clean my room. So it doesn't make sense for the resolve or the reject to happen at the same time. This is also important. It's one or the other, strictly. But we have to prepare for both of them. All the time, we have to prepare for both cases. This is very important in software. We never prepare for the success or the successful state. We always, and most of the times, we mostly are interested in handling the error cases or the bad cases. You know, the plane flies, everything works, but the one engine stops. We have to first take care of one of the engines fail, or maybe both, and then we say, okay, let's deal with how the plane works in 100%, let's say. Okay, so the question is, when do we use promises? So we use promises whenever we have an asynchronous function, a function that doesn't block the code. I will talk a little bit about this in the code. So whenever there's an asynchronous operation, something that starts executing, goes out there, does something, like connecting to a server, and then after some point in time comes back with a result, this is where we're going to use promises. Promises are about asynchronous operations. I'll talk a little bit about asynchronous so we all understand. So pending, I started doing, there's either the resolve state, I did it, or I couldn't do it, so I'm in the rejected. Now, if we go to the promise syntax in JavaScript, we will see that, of course, the result and the rejected are just some concepts. We describe what might happen in the future, but we have to write some code to deal with these two cases. So just like in an if statement, you say if and block. So let me write this. Promises. So an if statement analogy. So we have if some condition. And I will say here, if, let's say, condition success, or you might think of as resolved. So let me just turn this into a string so that we don't get any errors. Now this is very silly, but so in an if-else statement, we have the same sort of branching. Just like with promises. Let me see if I can find an if-else image so we can see that it's pretty much the same thing, but no, let me see. Okay. Let me see if this, okay. Diagram. Okay, I think this is a little bit okay. Low resolution, but doesn't matter. So you see, like an if-else statement, it's kind of like the promise. There's a branching. There's something that starts. there's a condition in an if statement, something is true or false, and then we branch to two directions. Either something is true and we go into the if code block, or it's false and we go into the else. So they're very similar in that something starts to happen, there's a condition, and then we go either on the left or the right, on the else or on the if. It's exactly the same. We don't have both if and else at the same time. That's impossible. And we deal with both situations with the code blocks. So here is how we handle, let's say, the success, and this is how we handle the error. In a promise, we call this rejection or reject state, and this is resolved. So in if else is handling synchronous operations, like really things that happen really fast. With promises, we kind of like do almost the same thing, but with things that are asynchronous, things that might take some more time. So let's say I will go, this is the if else, let's say analogy, and this will go to promises. And in promise, I will use a very, very common like promise-based function, fetch. So fetch is a promise, is a function that is actually working as a promise. So it's starting its work, and then you can either, I will put some code here, it will either resolve or rejects, and then you have this strange looking syntax for now at least. So this is the, let's say, else, sorry, this is the if, resolved, and this is the else rejected. So the syntax is slightly different. You can see the if else makes more sense, you know, if, then parentheses, and then a code block, but the logic is kind of like a similar in some way. So we'll go through the code. Let me go back to the to this example so we can. Okay, so we are in the resolved or the rejected. We handle both cases always. I would suggest that you start with handling the rejection first, so that you never forget to deal with things that go wrong. Just remember the plane analogy. If you remember the engine or the plane, I hope you will never start with them, but you will always start with cats. And then, of course, if we go through the resolve state, we find ourselves in what it's called, you know, the finish line. Now, in here, we have this this next promise. We will go through this in the code. I just want to focus on the first part. We will see where we finish up. Let me see if I can find some other, maybe. Oh, I think this is nice. Yeah, this is nicer. Okay, this is nice. So okay. So just disregard on the left side. We start with the left side where the promise starts. So there's a resolve and a reject. Disregard for the time being these things. Just think there is something that a promise starts, like a fetch or a printer start to printing and so forth. We get to the then, which is the fulfill state, or to the cats, and we run some code to handle that. And then at the end, we have like the finally state here, which is also actually a command. We'll see that. So this is where we eventually will end up after a promise has been fulfilled or rejected. We can either reject or resolve, but at the end, we will definitely find ourselves in this finally state. This is the end, the finish line of a promise. Now, before writing our first, let's say, code example, questions, discussion, ideas, things about the diagrams, the concepts before going into the code? And let me know if you want to switch to some other thing that we... Anything that comes to mind? And remember, this is one of the toughest concepts in JavaScript. Like, yeah, that diagram might be a little bit misleading, so let's clear things up. So let me get the... okay, so we have a promise that will start in pending mode, and then it will either reject or resolve. So let's say resolve. No, let me just use some resolve and then or reject. And in both cases, we will end up with the final state, with somewhere like here. Okay, this is like the finally. Like at some point, the promise must reach a state of finalizing. Now, this diagram might be misleading because in real life, or when we actually run a promise, we are going to see only two things. So let me just draw like the real, let's say, diagram. So I will go with the successful. So we have a promise, and then it will. This is a printer. It prints something. Okay, and then resolve, and then then like print the paper. So let's say this is like a print document. So there's if the printer works correctly, we will only see this diagram. There are no two branches, there are no things like this. We start the printer, it successfully prints the document, that's it. So one day that happened, nothing else can happen at the same time. Now, the next day we start the printer, we forgot to load the printer with inks, so we will go to this so there's no ink, we're out of ink, so we're going to go into rejected. And then, of course, we have to deal with this situation. We have to, let's say, alert out of ink. So we have to do something at the end of the day, like give the user. Now, these two things is how this process, this is like the finally. So let me just draw this. So this kind of like part, of course, is the finally, right? But you can see here in both cases, there's just one arrow, one like route. There are no branches here. Either we resolve and we print the document and we end up in something here, or this. So if we actually run a promise-based function, we will either see this diagram or this flow of execution or this. So one of these two cases will happen, and we have to take care of both cases with either a then or a cut. So there will be like a then here. Oh, sorry. So this is okay. This is buggy, so I'm going to so then print, and then here's the cuts. We will see this in code. alert out of thing. So the question is, if I understand correctly, like if we are in the bottom case, so we start the printer, it rejects, we catch, and we say out of ink. The question is whether we can restart the cycle, right? We can actually do that. So we can, let me draw. So in here, if the promise is like is a function called like fetch or print, we can actually run the command again, and we can start the process again. So we can do that, and we can say, okay, if this fails, run the promise again. The important thing here is, and this probably will remind you of an infinite loop in a loop. So if the printer is out of ink and we always try to reprint, again, we will always get in an infinite loop. Print, out of ink, run print again. So what you have to introduce at this point is some kind of logic that will stop after a few tries, okay? Print, reject, try once, try twice, try thrice, and then stop. So you have to write some logic to stop after a few tries. Otherwise, you will go into an infinite loop. So yes, we can run this cycle again, and we have to like stop at that some point. So it's a little bit it needs a little bit more care. Or I can say, just like with loops, as with loops, we have to be very careful about infinite loops and be very careful to stop them.
Counter maybe.
Yes,
Just a variable that increments
exactly
until it's 2, and when it's 2, then it will stop.
Exactly. So here we need a counter less than 3, something like that. So start the counter, start printing, try to print 1, twice, thrice, and then stop. So we can do this, but we have to stop at some point. I'm not
I
sure.
think it's bad practice. I don't think that anyone after the reject does something. I haven't seen it, but if you've seen it because you are a lot more experienced, you can tell me. But I think if the reject is the purpose of rejecting is to reject.
No, we see it a lot actually. There are many cases where we try, after we reject, we try a couple of times. We see it because let me give you an example. So you have like a fetch.
Sorry, maybe Leon can think of an operation what to do after the reject, like why you need. I'm telling you, like if he's able to think of some of the reason why you should do something after reject. I don't know if, because Leon said that you don't do anything after the reject clause, but I think he can think of something that is.
Yeah, maybe you can just put in the HTML warning or something. You can tell the user to reload the page, maybe, if you reject.
Exactly, like handling errors.
Yeah, just to handle it and tell the user to react to that error, not for you to automate all the process of what will be done after that.
So the question is, what do we do basically when a promise rejects? Like, is the user going to do something? Or so first of all, you have to think as programmers. So promises are programming concepts. So it's your responsibility to understand promises and do something with the rejection. So you have to write some code to handle rejections. Okay, that's mandatory. Never leave errors or rejections unhandled. It's a bad habit in programming. So something goes wrong, you have to handle it, right? Remember the plane. There's a good the plane flies and you're okay, and you handle like I don't know the drinks in the airplane, but something goes wrong, you have to handle the error. Now, when you handle the error, there are two cases. Maybe you do something that doesn't involve the user, like try to print again or try to do something again, try 2 or 3 times, so that eventually the user sees the printed paper or whatever you're trying to do. So one thing is that you can write some code and handle the rejection so that you do a retry or you, I don't know, stop the program. And then there's the part where you have to you should like do something that involves the user. So, for example, you write the code to retry, and of course, after let's say 3 retries, you can either fail or get the result. At that point, or during this process, you have also to write code to show something to the user. You should always remember and take care of the user. While your code is running, the user should be seeing something. This is the user experience, as we say. So if I open up my phone and I press, I don't know, low, and I see nothing, there's some code running, but if I don't see anything, I will probably close my application. So you have to write some code to go to some server or do something, but you also have to show something to the user. Now, most of the times when you try to do something, you show a loading spinner or a loading screen, right? So the user should be, oh, okay, something is working, something, I'm expecting something. If it rejects, you should also show something to the user. Sorry, network failure, or you're out of battery. If you try once more to go to the server, another message to the user. Network failure, trying again, wait 3 seconds, okay? If there's a success, also write some code to do something, store the result in a variable, and also go back to the user and display a message. So your like responsibility is twofold. As a programmer, you write code and make sure that everything works in your code, but also always remember the user. There's this user waiting for you to show them something. So you should keep both things in mind. Code for your program and also code for your user. So great question, and it reminds of what the responsibilities of a front developer is. Leon?
I think the most important thing is to check what type of an error, what is the problem of the rejection first, to analyze the problem of the rejection. As an example, most of the times we analyze it getting the HTTP request status, just to see what is really happening. Is the API's fault? Maybe it's not getting something from the API, or is it something else? Is it what error is it? Is it error 404 or something else? And then you are going to take these conditions and turn it into what you want to turn it.
Exactly.
Because you have to know what is really happening first. Until you come to the decision of what you will do at the end.
Exactly. So when we say we handle like the error or the rejection, we check a couple of things to see what happened, what kind of error, when, and then we deal with it also in terms of the code that's going to be run afterwards, and what kind of message we're going to be showing to the user. Of course, we get the error and we see if there's the error says network unavailable, we have to show to the user network unavailable or could not connect. If the error says like you're not authenticated, you're not logged in or something, we have to send another message back to the user. So exactly what you mentioned, like see what kind of error we have, what's the reason, and then show something a little bit more friendly to the user, of course. Right? You don't show to the user error 301 or I don't know 500 or something. You show to the user something friendly. For the technical people, of course, we know a little bit more about the status code. Okay, now I'm going to finish up this diagram and kind of like hope to have you all understand what happens. So the finally. I think I did a mistake before. So the finally goes here. So this is the finally state. I think my earlier like diagram was not. So we either go through promise, resolve, print, and then we reach the end finally, or the reject, or maybe to do it a little bit differently. So we have like just in mind like two cases that can happen individually. They can never happen like at the same time. So I think this is much better. So think as the first one being on Monday and the second one being on Tuesday. They cannot happen at the same time. There are different things that happen in linear fashion. So both of them, like both promises, can either resolve or reject, handle the error or handle the success, and then finally they will both reach like the end point. So we will go to the finally in both cases. So that's it. The thing that's kind of like a little bit like different is, of course, where things will be a little bit different is this part. So this is like the branching. But we always start a promise in pending mode, and then we reach the finally. But in the middle, we have this, you know, either this way or the other way. Okay. Any other things before we try to write some code and maybe see this in a more practical manner? If something is not clear in this conceptual level, I think it's important to clear this before we go into the code. The question is, where do I see the error when a rejection happens? So that's right here. We will see how we can pass some parameters to this function, and we can. Okay. Any other questions, ideas? I don't know. Something that.
The cross origin, but after.
No,
maybe.
let's leave it out of the discussion. It's
Yeah.
completely different. It's a good, we have to cover it, but anything with this promise concept before diving into code?
Why do we need finally? Do we need finally, or we don't need it, and why?
Yeah, that's a good question. Okay, so let's say that we have, let's come up with an example with a promise. Okay, we have the printer. Okay, let me start with an example, and then I want you to think of another example. So let's say that we have a promise to print something. So in one case, the printer works and it resolves and it prints the document. And okay, we just handle the printing thing, and we I don't know, read the document, or it's out of ink, and then it's like we handle that error case, we display a message, and that's it. Now, in both cases, is there a thing that we can execute, or a thing that we can do? Sorry, forget execute. Like think of the printer. Is there a thing that we will do at the last step, at the finally, in both cases? So imagine this: you go into an office, you turn on the printer, it prints or it doesn't print. Is there something that you will do at the end in both cases? So you go into a room, someone asks you from the office to print some documents. So they will say, go on the second floor on office A, B, whatever. You go in there, you turn on the printer, it prints or it doesn't print. And before you leave the office, what do you must do in both cases? Exactly. That's where the finally comes in. In both cases, we have to we have to turn off the printer, right? We don't want it to be running. So that's where the finally comes in cases where, in both cases, you have to do something. It's not always the case that you have to do the same thing in both cases, but in the printer, you have to turn off the printer. So switch off. That's the thing. We will see another finally example in our code. So I will switch to code now. Now, for working with Codeben, just to make things a little bit easier to be clear here and read, I will introduce you to a JavaScript concept that not many people know. It's also a nice way to show off your skills even to senior programmers. Not many senior developers, JavaScript developers know this, but in JavaScript we have statements. We have the return statement, we have the if statement, we have the while statement, the do. So there is this category of instructions, let's say, that we call statements. And if you go to MDN and you search for JavaScript, MDN statements, you will find a list of things that you can use, the return, all of this. Now, there's a kind of like, let's say, hidden feature in JavaScript that allows you to use a label before each statement. So before each statement, this is called labeled statements, and it's labeled. So before every single statement, before an if, before a for loop, before a while, before a return, I don't even remember the statements, you can use a label, some kind of word, colon, and then the statement. Now, we don't use it too much because there's rarely a case that we can do something with it, but it's really interesting. So if you have like an if statement, you can actually, if let's say false, I will say, okay, if false alert, so we don't get into the, okay, you can actually label this like my first if, and you can do this thing even with spaces. So that's just labeling a statement that's going to come after. Now, in this case, there is no reason to do this unless you want to describe either to yourself or to other developers what this if statement is all about. So you can do this. The reason I'm mentioning this is because I'm going to be using the label statements in my codes so that I can have a more clean like environment. So I would say promises, if else analogy. So I can also use this code block, the statement that defines like a code block. I can put everything inside. And then this for me, it's like a nice way to organize just my examples in like a package. So this is just a label statement. This is a code block, and then I can label it. And for me, the only reason that I do this is during the examples, I can just fold it, and then I will get this. I will get rid of this code, so I can go to the next code, so we don't have to scroll. So as I'm going to be using it, I want you to understand this feature and maybe use it. Now, another thing that's really nice about this label statements is that when you use it with a code block, I will add a console log here. So console log end of block. Oops, you see this. Okay, and you will see the whole code executes. So if I see the last command being executed and see the console log, it means that everything ran correctly, right? If something bad happens, if I put like an undefined variable here, the code will break. The A is not defined, so I will never reach the end of the code block. I will never reach line 20. Okay, so console log end of block reminds me that everything successfully executed until the end. Now, I can use a statement called break with the label, and this will stop execution of this block. So this is like putting the brakes and then saying, okay, don't execute the rest of the code, just break here, just go elsewhere. So in this case, I'm also using the break to just stop this code from executing. Because I'm going to be going to another example, I say I don't want this code to be run again and again while we're seeing something different. So the break also allows me to use the name of a labeled statement and then break that statement. You can use this in while loops, in for loops, so you can use it in other statements. But for now, just to understand, this is a label statement, label, colon, and here's a code block, and then just stop the code from running. Okay, so this is mostly to understand why I'm going to be using this thing. So simple fetch promise, let's say example. So I'm also adding another label statement. You can see that I cannot use spaces. I cannot do this. It's the same convention with variables. We cannot name a variable like with spaces, right? So I have to use underscore or some other symbols. So I will use the underscore. And then I will work with a fetch. Okay, so fetch is a promise-based function. It's a built-in command that you can find in the browser. So whenever you're running JavaScript in the browser gives you this capability. It gives you this fetch command. The reason why I'm saying this, I'm explaining this way, is because JavaScript is a language that can run in different environments, and depending on the environment that it runs, for example, you can run JavaScript on the browser. You can run JavaScript on like I don't know, a car, a refrigerator, a smart TV, even a software like Photoshop. So you can run the language in different environments. And today I learned that the big company called Oracle, which deals with databases, it's going to be introducing JavaScript inside its databases. So from today, I think we have a new environment where JavaScript is running, databases, which is pretty exciting. So you can run JavaScript in many environments, in the browser, on your system, using Node, on a smart TV, on your mobile phone, and so forth. In this case, we're running JavaScript inside the browser. And when we run JavaScript inside the browser's capability to connect to servers. So whenever we open up a page, our browser connects to some server. So the browser lends this command to JavaScript, and it allows us to connect to a remote server through this fetch. So this fetch is kind of like a loan or a gift from the browser to JavaScript, right? JavaScript is a language, it runs in different environments. In some environments like the browser, we get some gifts from the environment. So the browser hands us like the fetch. Another gift that we get from the browser is the camera and the microphone. So since the browser can also access our camera and our microphone, it also hands us some like commands to JavaScript that says, hey, you can use the microphone or you can use the camera in your JavaScript programs. But it's important to understand the distinction. These are some things, I would say for now, gifts that come from the browser, from the environment. The language itself doesn't have anything called fetch or camera or microphone. This is something that the browser gives to us. Let's learn about fetch. So fetch, and it's a, so fetch, first of all, fetch is a promise based function. Whenever a function in JavaScript is using this promise then catch thing, we call that we say that this is a promise-based function. So we have to run fetch, and we have to supply a URL, a web address. Okay, so fetch can go out there to some web address, to some server, and get some details. So let's find the I don't know, like a nice server. JSON free developer jokes. So I will try to reach a server that responds with some jokes. Let's see if I can find. Do you remember any free joke API, Abed?
Free joke API.
Or some silly API? Let's see whether
Chuck Norris has jokes.
Yeah. Okay, we do get a question. Okay, I think that's it.
I love my Rick and Morty.
The what?
Rick and Morty.
Okay, let me just find some. Don't worry about it. Just checking, then we will respond. Okay, this is not Chuck Norris. Let's see, Chuck Norris. Sometimes Chuck Norris jokes are really silly, but let's get this. Okay, so okay, what is this Chuck Norris? So basically, it's like a server. It's a computer that's connected to the internet, and whenever we use this web address, the browser goes to that server and asks for a response. And the response that we get back from this address is a random Chuck Norris joke. So this is a JavaScript object notation. So this is pretty much like an object in JavaScript that has different properties. That the punchline is this one, like value, Chuck Norris is made out of titanium, blah, blah, blah. Okay, so whenever we go to this address, we get a random joke every time. Okay, that's why I guess. Okay, so sometimes the jokes are really, really silly. But for now, we will use it. So whenever I go to this web address, I get this this result back. Now, this result is just a plain text response. So this is what we get back. I use a oh, hello. So we use this. I use this extension that kind of like formats this text, and I get to see it in a much nicer, highlighted, colored version. And basically, what I get is this object, and I can get the joke out of it. So I'm going to be using this URL, this web address. So fetch, I have to put the URL inside the as an argument. So I will store this in a variable, and then pass it to fetch. Now I will open the real console and see whether I can. Let me. Where is it? Okay. I will try to. Okay, let me make this a little bit bigger, and I will go here to the real console. Okay, so I'm fetching. Let me see how we can actually. I'm trying to find a way to see. Okay, the screen is. Okay, the thing I want you to see is that when I run this command in my code, I can open up the DevTools and I can go to the network tab, which shows me everything that goes between the browser and then any external server. So whenever the browser connects to everything, anything on the internet, I get to see it here on the network panel. Let me try the side panel again. And let me make this bigger. Now, I'll try to hide some things here. Size. Can I hide this? Method. Okay. Or okay. Let me just. So I will run the code with fetch commented. Let me run this again. So let me update. Okay. So whenever I run my code, it automatically runs whenever I change something. Okay. There's some network requests that happen. So this page actually goes out to some servers, some computers out there, and does a bunch of like requests, requesting some HTML files, some CSS files, and this don't make too much sense at this point, because this is the CodePen platform that has to request some files so that we get to see the application here. So don't worry about these things. These are things that CodePen depends on. Now, if I run the code, if I clear, and I can filter the things that I see here by clicking the fetch. So if I click this, I will not see all the requests. I will see only the requests that happen through the fetch command. So if I now uncomment this command, I will see that there are 3 fetch requests happen from CodePen. So these 2 things are CodePen things. I don't care about them. Someone wrote the application. Now this is the fetch that I'm running here. Remember in the previous screen, we didn't see any random Chuck Norris fetch. So, and I see CodePen still runs some fetches for some reason. Now, this is what happens when you call the fetch command. The browser does a network request to the address, API, Chuck Norris, this is IO the domain, and then, the jokes is the path, and we get some response back. So, let me see, no. So in my network tab, I can see the request URL, the thing that I try to request from the server. And then I get to see some information about what came back. This is the response I got from the server, and the headers are some special information that the server sent. And then I believe that's a response. I can go to the response to actually see the package that was responded, that the server responded. So this is the package that I got back. The headers are some special information, but this is what the URL, this API Chuck Norris gave me back. So you can see this looks like a JavaScript object, and it contains a silly joke here, the value property. So every time I run this, the browser goes to this API, to this URL, and we get back something. Okay? Now, questions at this point? Let's start with the question. We will finish the fetch, and then we'll have a break, and we'll continue after. Okay, Leon, you wanted something?
Yeah, where is that all this information coming from? We get some information, there is a response, and we get some information right there at the response, the status, the headers, and everything. There is just some information about our request. But where is it coming from? Is it set from a server? Is it automatic? Can we set it also? If we had an API like the one we use, could we just set all this information by ourselves? These questions.
That's a great question. So let's see. So when we do a request through the browser, there's always a request object, let's say, that contains some headers. These headers. So this is some special information that the browser sends along with the request. So whenever we open up an address, like this one here, CodePen, Costa6, blah, 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 or Google, or whatever, or Gmail, or we use like a fetch command to actually make a request, we not only send this URL, this web address somewhere, we also send some, the browser sends some extra information called the headers that we don't see unless we open up the dev tools. So I will draw a diagram here to understand this. Or where is my web napkin here? Okay, let me just download this picture. And then I will. So where does this information is coming from? That's a great question. So I want you to think of this as the browser. So this is the browser. Okay, and here's a silly cloud that's the internet. Okay, so the browser or the computer is connected to the internet, and then out there are like a bunch of other computers that we can connect to. Okay, and these computers are called servers. So let's think as boxes. So these are servers. So basically, a computer connects to other computers through the internet, right? Roughly simplified. So this is the internet, and this is like, let's say, Google. So this is like the Google server, and this is, I don't know, like whatever, like Wikipedia server, and this is the some other server. So all these computers that are connected to the internet are either clients or servers. Servers are there to serve, to respond with some HTML or some data. Clients are there to just request these things, right? So we have this distinction in the web. Like there are machines that act as clients. They just go into the shop and ask for a coffee, and there's a serving part which says, okay, here's your coffee. So there's some computers called the servers that provide the coffee, and there's some computers that just ask for coffee, okay? So whenever our browser sends like, let me put this, whenever we use an address, I can even use the, like HTTPS, I don't know, jokes, whatever, right? So whenever let me put this, yeah, and let me make these jokes. Okay, so whenever our browser makes a request, or even when we use the fetch to do a request, the browser sends a couple of things. So this will just start the request that, first of all, will contain the URL, because this is how the internet will have to find a way to get to the, let me put another column here. So the URL will help us go and find our way in the internet. So this is the address, okay. But on top of this URL, the browser also sends a packet of things called the headers. So, so along with the URL, along with the request, we also get some headers that the browser sends to the server. So this thing actually ends up here, okay, URL and the headers. And this header is just some text that provides some information to the internet, like to the intermediary, let's say, stations here. So whenever you have to reach jokes.com, you have to go through a series of network switches of other machines. There's never like a direct route to your server, to google.com. We connect to different computers in between. So these headers provide some information for these intermediary machines, so that they know, let's say, how to route the request, or maybe about some things, I don't know, that are involved in this process of finding our way through the internet, or they provide some extra information for the end server, for the jokes.com. So for example, in the headers, I might say that my language is like, let's say language is Greek, okay? So, hey server, I want to give me a web page, but remember that I'm using Greek in my browser. So if you have some Greek, send me back the Greek. Don't send me the English. So we pack this, the browser packs this information in something called the headers. So you can think of it as a small file that is sent through the internet to the server. And some of this information are set automatically by the browser. For example, the language, the ways that the browser, the capabilities of the browser, maybe your browser can compress things, so you can actually send and get back responses and requests that are smaller. So it can compress things and decompress them, so you can send smaller packets. So there is this information that is actually set by the browser automatically. Or you can even set these headers yourself. So through JavaScript, you can also add your own headers. We will see more about this in the upcoming lectures. For now, just you have the only thing you need to know is that you can also set this yourself. So this is like a special extra package of information that is sent every time your browser does a request to some server. Whether that's like just opening up your browser and typing, you know, Google, let's say .com, there's always these headers. If I open up the network tab, you will see I'm making a request to, like, I think this is the document. So this is the the domain I'm reached. And oops, no. And if I click, you will see the headers. So there are actually two packets of headers, one that go from the browser to the server, and another package of headers that come back from the server. So in my diagram here, when I get the response, so when I get the response from the jokes.com, back here, I also get some headers. But these are like the headers from the server. These are, I don't know, like I'm secure. Sorry. I'm secure, so if you want to pay, you can use your credit card, something like that. So there's always headers going back and forth between servers and clients. You can see these headers in here, network headers. So this is what we send. This is what my browser sends. You see there are 19 headers when I go to google.com. So the method, this is the HTTP method, this is the path. Some things that really don't make sense at this point. The scheme, the HTTPS protocol, this is the secure. The language, you can see that my browser starts with English, Great Britain. So my first language of choice is English. So the browser says to the server, give me back English if you have. If my browser was set to use Greek as the first language, you will see here, I think it's GR or EL, Greek. And then the Google or server would respond with a Greek page. And it would say, kalos ήρθατε, not Google search or I'm feeling lucky. So I could probably go here. So this is the language, and then some other things that really, I have no idea. Yeah. Some other information that the browser needs, but we cannot see. Okay, so these are the headers. They are going back and forth between server and clients always, and on both the server and the client, we have some of them being created and sent automatically, and we can also set some of the headers. So the quick answer is that we can also set these headers. Now, let me go back here. So the fetch is going to connect to some URL and get back some result. So I will go here. Now, I'm running this code, but I don't see anything else. Let me just run console log here and off block to see that. Okay, I see that I read this, but even though this fetch actually makes a request, I don't see anything back. I don't get to see anything. So where is the response? The response is being returned from the fetch command. So this will actually go to the server, connect, and give me back, return back a value. Now I can console log this value. I can directly console log the return value of a function. And I can see that, let me just filter some of the, okay, so what I get to see here, what do you see I get back from this function call? There's something that reminds there's something that reminds us of what we saw earlier in the diagrams, right? So I get back a promise in pending mode. Remember, we send the promise to get back some data, and we're in pending. So we have to either resolve or reject. So if I go back to the diagram, I'm here. And now the next steps is either resolve or reject, right? One or the other, and of course, handle these cases. So at this point, I know that whenever I execute the function fetch, it goes out to some server, and then it brings back a promise that will either resolve or reject. Now, instead of just directly console logging the return value, the result of the function execution, I can store this in a variable and console log the variable. So the same thing, but it's much more clear that the evaluation of this function will result in something which we saw was a promise. I'm saving this in a variable, and then I can say console log response. I will see exactly the same thing, but now the code looks a little bit more clean and it's more readable. So in this variable, I have a promise. Now we're going to take a break. If you have a quick question, we can answer it. We'll take a break, and then after the break, we will go to see the actual response, resolve, reject, and so forth. But now we see that in the technical level, we see the parts that we saw in the diagram. The fetch sends back a promise that is promising to get something from the server, and it will either succeed or fail.